my name is Billy Korando. I'm a developer advocate with IBM. You can find me at Billy Korando on Twitter. You can also email me, william.korando@ibm.com. My DMs are always open, so if you have any questions about this presentation, Spring, Java, IBM Cloud, or anything like that, please don't hesitate to reach out and ask me a question. I will be more than happy to answer any kind of question that you might have. I got into developer advocacy because early on in my career, even still now, oftentimes I find myself lost and not quite knowing the answer to something, and I got into this to be able to be a source of a place people can go and ask questions whenever they are curious about how to learn more to be better developers. So a couple quick things. Part of my team, what we do is at the Global Java Developer Advocacy team at IBM, we do a monthly Java newsletter. So if you just kind of want just a kind of a brief idea of what's going on in the past month of Java, or maybe what's going to be coming up, check out our newsletter. We also kind of cover maybe upcoming conferences, but just kind of what's going on in the world of Java, which is, becoming much more fast-paced since the recent switch to the 6-month release cycle back in 2017, or I guess maybe more technically 2018. Also, Oracle recently did some licensing changes to how you can run the Java JDK or their Oracle JDK, and that kind of caused some shockwaves in the community. So if you've been kind of wondering how to best run your Java workloads and not have to worry about support costs and licensing costs, definitely consider adopt OpenJDK. It's a really great source. It has JDK downloads for all the different platforms, and they also run mini tests to make sure everything's good and it's all transparent. So it's a really great source if you're wondering where to go if you want to move off of Oracle because of all the licensing costs. Lastly, if you do have an intense desire to know more after this presentation, I have blogged a lot on automated testing and also specifically a lot of the content within this presentation itself. So it's like, oh, I would like to know a little bit more about this area, or just maybe something wasn't quite clear, I didn't go through during the presentation. Check out that link. Like I said, it's a bunch of links to a bunch of other times I talked about automated testing to get some more information. So how many people here have done contract-driven development before? One, so a couple. So yeah, and that's fine. I kind of expected most people haven't, and to kind of get people in the headspace of what this has nothing to do with lawyers or anything like that. I'm just going to give a very quick high-level overview, and then we'll get deeper into it later on in the presentation. So at the very high level, contract-driven development is defining the behavior of an API in a programmatic way that can actually be then tested and executed and checked against. So pretty much what that means is like you're going to have a client and you're going to have a service that's going to be backing an API. And so a client is going to send some sort of request, API, V1, customers, something like that, to some sort of endpoint. And if it's a GET or a POST, or if it's a POST or a PUT or something like that, it may also have a body within that request as well that's going to contain some sort of content. So based upon if a request looks like this and it's sent to the service, then the service should respond in some consistent, specific way. It's like, okay, this was a good request. We're going to send back a 200 response, and within that request or within that response, the body should look something like this. So what contract-driven development is writing out this behavior, what kind of request comes in, or what kind of response comes out based upon certain parameters in a way that can actually programmatically execute it against, so it can be checked against by both the client and the service without actually having to connect to a live instance to make sure that checks. So we'll get deeper into that, but that's a real high level of what we're going to be talking about. So why should you care though? It's like, oh, okay, I maybe can go through this presentation and just say all the things of how to do contract-driven development, but that doesn't necessarily answer why you should care. And so when I was putting together this presentation, like one of the things that kind of popped into my head, and some other presentations I watched, is like there's a scene from It's Always Sunny in Philadelphia. One of the characters is seen taking a bag of trash through a bar all the characters own, and they're asking what he's going to do with it. It's like, well, instead of throwing it in a landfill where it's just going to be there for thousands of years, he's going to light it on fire, and it's going to become stars. And none of the other characters are like, well, that doesn't sound right, but I don't know enough about it to say you're wrong. So kind of with that, let's kind of look at some of the reasons why you should consider moving to contract-driven development, some maybe pain points maybe we've all experienced as developers when doing development without contracts. So I put together kind of 3 scenarios that I kind of experienced with during my career. Before as a developer advocate, I was a consultant, and before that just also as like a normal staff engineer. And these are some of the things I kind of ran into at multiple points. So the first one is kind of working with that existing poorly defined service. Like it's like, oh, maybe it's like some third-party service, or it's just some old service that your organization has been running for a long time, and it's just very difficult to work with. So like, let's say, for example, it's like a customer information service. So yeah, you, the client, needs customer information service, and it's like, you want to use my API. Okay, did you read the documentation? Yeah, it's in this nice Word doc. If you want to get customer information, you call get customers. So it's like, okay, HTTP get customers, but it's actually a post endpoint. So I call it get customers, but nothing's coming back. 405, wrong method. So post tries that again, still getting nothing back. Well, you need, of course, to send the authorization header. So he sends all of that, but then the service is crashed, sends back a 500, and well, the database that's backing that service is down. It sends back like an HTTP 200 with like an error code in it, and just none of it makes any sense. Sounds like from the chuckles, like people have run into that experience before as well. So kind of what's going on here. So we have like a poorly defined or undocumented API. So yeah, there just could be parts of the API that just aren't defined at all. And it may also be in a format that's just really difficult to use, like a PDF or a Word doc, where it's just not something that's really conducive to taking that out and taking that into the code that you're going to be actually working with. We also maybe have inconsistent behavior or patterns. Kind of an example I have of that in that little scenario was, for example, they had like an endpoint called get customers to get information back. So you would kind of maybe assume that should be a get call, but it was actually a post. And maybe other parts within the API, maybe they are doing proper RESTful patterns, but because sometimes that poor documentation, it can be hard to see when certain patterns are not being followed because no one has like that full view of what everything actually looks like. And lastly, testing against live services can lead to inconsistent results. So data can go missing, misconfiguration to where something could be down, a whole bunch of things. Was anybody in here attended Angie Jones's talk yesterday on visual testing? Okay, so one or maybe 2 people. I think this particularly can be interesting from a front-end perspective or for kind of stuff that she was talking about, where you can get more consistent results, which we'll talk about here once we get to really contract-driven development. So another kind of problem is, okay, so you're going to be, say, building out some sort of new service. So you're going to have like both the service and the client consuming it, or maybe new features within an existing service. All the same, you kind of go through all those design meetings, and you're ready to actually start building it out. And you, maybe as a client developer, is like, okay, I know exactly how I'm going to be working with this service. But oftentimes, kind of what happens is that that service developer actually has to build out that service API before you can maybe really begin work, because you really don't know maybe quite what the API is going to look like. Maybe you think like a field is going to be called first name, but then like the developer actually names it like F name or first underscore name or something like that. So maybe use a client developer wait. So service developer is like, all right, freeze, I'm going to write this service out. And like the client's like, hey, is this order endpoint ready? No, they're making a change to it. Hey, hasn't even been finalized for it. Now they're going to be like just updating and changing the model. And kind of what ends up going, and then like eventually gets pulled into a prod issue. And now all the features and all the work you want to work on is just frozen while the service developer continues work on it, or is pulled off into another area, and you just can't get any work done. So yeah, an inability to develop in parallel. Client developers often have to kind of wait until that service developer has built out the API before they can really get to work. Maybe you can get some work done initially, but sometimes it's just a limit to it before you can actually really start developing your side of the new feature or new application. And so what this leads to is like delays in the development, because anytime like that service developer is delayed while they're building out the API, that's going to necessarily then push back what the client developer can actually do. So if a service developer gets sick, gets pulled into a production issue, goes on vacation for whatever time, that's pretty much about the amount of time that that service is, or that new feature or new application is going to be pushed out before it can be delivered to production. And then also sometimes, like a client developer, they may have to wait a while, or they may have to get back up to speed. So they go through all the design meetings and they know exactly how they want to approach it and work on something. But 2 weeks go by and it's like 5 production issues, 10 tickets and all that stuff. And all that knowledge and how they want to consume that service is just completely gone out of your head because you've just had to work on so many other different things. And so the last one, I know I've done this to many client developers during my career as a service, mostly working on a backend services, where I push the change up. So maybe you have like an over-eager developer like I often was, and like I saw from like that first scenario, like someone said get customers. I'm like, oh wait, that's not proper RESTfulness. I'm going to update it to be like customers. So I, as a service developer, made that change, and maybe here's what happens. Like, so it pushes that up to production, and no one told the client developer that it was going to production, and it was actually deployed last night. And it's like, okay, well, he'll just have to stay late tonight. Good, and also I'm pushing up a change to the model as well. And yeah, no one tells them what's going on until it's too late, and they're always the last person to know, and they're always fixing these production issues. So yeah, breaking API changes often are not caught until production. If maybe a QA person didn't know a change was happening, they wouldn't know to have to test for it. So it just goes all the way through to production and leads to some major potential outages. And then also kind of what happens is a lot of the API design is based upon what the service developer wants to do, because the client doesn't really have an opportunity to say, hey, actually if you design this endpoint this way, or if you design the model this way, this would actually work much better for me. It's really just the service developer, however he or she thinks it would best be designed, is how they're writing it out. And that can kind of lead to some friction where maybe the client is maybe having to make a lot more calls, or just having to work with a weird object or model that doesn't really make sense for how they would actually be working with it and consuming it on the front end or on their client side. So let's actually start speaking in detail of what contract-driven development is, and specifically using Spring Cloud Contracts. So I've worked with Spring for a long time, for about a decade now, but why should you consider it, even though I just kind of use it? So for one, it's a very active project. It's not like they have like one release or 2 releases like 6 months ago and they haven't touched it since. It's ongoing development. Even in the time since I've been using it, they've made a lot of changes to it, and they have a lot more changes they're going to be continuing to work on. So if you find a bug, you can submit an issue, they're going to fix it. It's ongoing and actively being developed. It's also interoperable with other tools and standards. So if you already have done like OpenAPI, Pact, Swagger, there are some third-party libraries out there that can like take in like your Swagger docs, turn them into contracts, and then you can actually test them against using Spring Cloud Contract. So that way you don't have to like throw out all this work you've maybe already done. You can actually take some of that in and then maybe get some more value out of it. I would say I haven't used these third-party libraries. I just know they exist, so I can't give like real detailed answers on how well they work. There's also really flexible documentation support with Spring REST docs, and I'll demonstrate that a little bit later on. But finally, and importantly, to the collaborative portion of this, there is polyglot support, and I'll also demonstrate that here towards the end of the presentation. But the documentation is really great for this project, so definitely consider going to that link to read more about it beyond kind of what I show in this presentation and in my code demo. So what do these contracts look like? So there's many ways to write it. When a Spring Cloud contract was initially released, they did it all in Groovy. So in this contract here, what you see is an example of making a call to a post endpoint, API persons, and within that body, we're going to send like a first name and a last name, and it's going to be like a string like John and Doe. And then we're going to expect to have a content type of application JSON. And if someone sends a request that looks like that, then the response should be 201, HTTP created, and then also a link to that newly created resource. So that's kind of what this looks like, and that would be tested against. It would be tested against both the service to say that their API is acting this way, and then the client could then use this contract to say, if I send a request like this, can I consume it correctly without actually, again, having to connect to a live service. So how this would work is you would put this as part of your build pipeline, and you would have like your Spring project potentially set up to use Maven to check that against it. And so the contract would check the service, as I mentioned, to make sure that it is actually fulfilling the contract. And then you can take all these contracts and create like a stubs artifact, so that way other clients can then check it, and you can put it into this artifact repository so that you can then share it with other people, with other teams or potentially external clients. So again, they have something to test against without necessarily having to connect to a live service. You can also take these contracts and, as I mentioned, generate documentation from it. So you always have a current documentation as to what the API looks like right now. And then beyond that though, because these contracts are testing the service to make sure they match, you know your documentation is matching the current state of the API. It's not like, oh, this maybe is sort of what the API looks like. No, that's what it really looks like right now, because again, it's got tested against it and is being automatically generated. And then finally, a client can then test against the stubs artifact to make sure it can actually connect to the service and use it correctly, again, without actually having to connect to the live service. So this can all be put into your CI/CD pipeline. It can be nice, fast, and also extremely reliable, because you're not going to be running into issues like test data going missing, a service being down, or any of that kind of stuff that can cause tests to fail for reasons that you don't really care about. So to quickly just review this, so you write the contracts to define the behavior of the API. You can the contracts and validate the API matches the behavior. You bundle the contracts into a shareable artifact. You can generate documentation from these artifacts, from these contracts. And in Flask, you can have clients test and develop against them. But really critically, those last 4 steps, other than of course the develop portion of it, that should all be automated as part of your CI/CD process, so it's always being checked every time. So that way, you know, if you get like an eager developer like myself, makes a change to the endpoint, that's going to be caught, so it doesn't actually say get to production. You can be just much more confident about how your applications will work once they get to production, and you can actually, again, do something like a continuous delivery pipeline. But how can we actually really get service developers and client developers to really kind of buy in and collaborate and build contracts together? So there's a couple of different ways of approaching this. There is quote unquote producer-driven contracts where the service developer that's defining the API, you know, they'll write a contract like I showed earlier and this says, hey, this is what the API is going to look like, and the client developers can be like, okay, that's great, so that they have something to test against. But you can also have consumer-driven contracts where a client developer says, hey, this is what I need from the API or from your service, and then the service developer will then write the service to build like that. So the difference between consumer-driven contracts and producer-driven contracts, the actual contract would look the same. It's just a matter of like a push versus pull in how you do the design of the service. So producer-driven contracts, the producer is kind of producing or pushing out, hey, this is what the API is going to look like. Where at the client, it's a pull kind of process where the client's saying, hey, this is going to be what I need from the service, and to build it out like that. One advantage from the consumer-driven contract perspective is you're only building out API based on the actual need from your clients. So you're maybe going to have less that issue of like Yagni, you're not going to need it, where you're just building out a bunch of stuff that isn't actually going to ever be used by the client. So, and then also you're also building stuff out in a way the clients would actually like it to have it built. So that can also be a big benefit as well. But both approaches are perfectly valid. The most important part would be to actually write the consumer-driven or to actually write out the contracts. But we need to have collaboration. We want to be able to have a better utilization of developer time. You don't want to have it to where you only have one person who knows how to write these contracts out or require a lot of tools to do that work. You also want to have both the producer and the client to have input on the API design, and then this can lead to more buy-in from all the parties, so everyone's a little bit happier. But you can't spell collaborative without polyglots. Well, okay, maybe that doesn't make much sense, but what is important though is we have language-independent tools. So what I showed earlier is how Spring Cloud Contract, you would write it out with Groovy, but that would require the JDK, Maven, and like a Java-friendly IDE. And while Java developers would have all of that, JavaScript developers or any other kind of developers are going to be much less likely. But what is becoming much more likely, though, is for everyone to have Docker, and well, every developer is going to at least have some kind of text editor, because obviously that's how we actually write out code. So it's actually been about a year and a half or so now. Spring Cloud Contract started being able to do better polyglot support, and one of the first things they did was allow contracts to be written in YAML. YAML, isn't perfect because of the meaningful white space, but it is language independent. You're not going to have like a Java IDE that can kind of nicely read and format Groovy to kind of work with it. So that contract I showed earlier that was written in Groovy, this is what it would look like if it was written in YAML. And all the functionality that you could do in Groovy or any other language is also available in YAML, so you're not losing anything by using it this way versus any other way. Then they also provided a couple of Docker images, and in these Docker images, it encapsulates all the Java and Spring Cloud logic for reading these contracts and then either testing the services matching the API that you specified in the contracts, or acting as a mock of that service so the client can then test against it. But this way, like a JavaScript developer, all they need is Docker to use it. They don't need to have like Java and Maven and a bunch of stuff installed on their system to be able to use Spring Cloud Contract. And so yeah, the client can then just use Docker, and it can read in either the stubs artifact or a contract artifact to test against it. And same with maybe if a service developer and you are writing like a Node service or a .NET service, you can even also still have a Docker reading of the contracts and then also test that service API to see if it's following it. It doesn't necessarily have to have backend services written in Java or Spring or anything like that. So let's actually see what I was talking about in action. So this is the GitHub repo I was mentioning that it's linked to in that bit.ly link that I showed earlier. So in it, in this GitHub, I have 4 different contracts. And in this contract, I am showing what would happen if I wanted to add a new item to this produce service. So I have like a post to this API v1 endpoint, or v1 produce endpoint. It's supposed to be JSON, and like it's supposed to have like name, subname, and quantity. So there's other ways where you can make the contracts more flexible. So here I specifically say like application JSON charts at UTF-8, but really I just care that it's JSON. So as long as within the content type from the client that's saying it's going to be application JSON, that's fine. And again, also within the body itself, instead of saying specifically you have to send the value of Kiwi, only having the name that it has to be alpha characters. It doesn't matter really beyond that. I just want to have you sending me like some sort of like name, not just like numbers or something like that. And similarly, also with quantity, I just have it checking to make sure it's numeric. It doesn't really matter whether it's 0 or 1 million. It just needs to be a numeric number within it. But this is just to demonstrate how there's flexibility within these contracts. You don't have to set it up to be super, super specific that it's only these exact values, because sometimes you can then run into like you're never properly maybe testing edge cases, or you don't really know what the boundaries are to it. So you can make this even more flexible, like saying like it should be only alpha characters, and it has to be between, like, let's say 5 characters and 30 to kind of also give an idea to your clients of kind of a better idea of what valid content looks like. Anyways, assuming a client sends a request that has both at least the name field and the quantity field supplied in its JSON, I should send back as a service a 200 HTTP status. I'm going to send back basically what they sent to me, but I will provide an ID and then again the name that you sent and the quantity. And again, within this is an example of if I'm testing against the live service, maybe the ID will be different sometimes based upon what's actually in the database or something. But what I really care about, again, is that the ID field is being supplied and that it's numeric. The specific number, whether it's 10 or 100 or 2 or whatever, that doesn't really matter too much. I just want to make sure it's there. So again, that's a way of how you can provide flexibility. And you can also even provide it to where to say that like this field should match what was sent in from the client. I'm not doing it here, but there are ways of doing that as well, again, to provide flexibility in how these contracts are used. So that's one. But of course, every API, there's going to be many different kinds of interactions. So for example, I have like a GET going to the same endpoint, and it's just going to say, hey, here's a bunch of different little produce items that are coming back. Or maybe looking up by a specific name or field or something like that. But lastly, so far, all those things are showing like happy path or good interactions, but you can also show what happens when like clients send incorrect information. So in this example, the name field isn't being sent, but it is actually required. So in that case, if that was to happen, then a response of 400 should be sent and like an error message should be responded back. So you can both define both good behavior and then not bad behavior, like what happens when errors happen and stuff like that. You're not just relegated to happy path interactions. Now, to keep in mind though, when you're kind of specifying this, is how Spring Cloud Contract, it uses both the HTTP method and the URL to create like a key. So because both this one and the first contract I showed were having both the same method and URL, you would need to add this priority in there so that way it can differentiate it, and then like it can have like an order of precedence on how these would be checked within Spring Cloud Contract. So there's something to kind of keep in mind for when you kind of have this behavior of like, here's like a good behavior, here's a negative behavior, and other kinds of behaviors for like the same HTTP method and endpoint. There are ways to do that. You just use the priority field. So let's actually see what happens. So here, I built out a service that is kind of based upon those API. And let's see what happens if I run Maven test. And as I'm letting that run, we'll take a few moments. So within a Spring project, I can define the Spring Cloud Maven plugin to then run these tests as part of my Maven build process. And then here, so like I would only really be interacting with the controller layer, and I'm providing a test class that then kind of simulates the backend behavior and logic, saying like, hey, when someone is calling to see all the produce, like then this is what should happen. I'm using Marketo to say, okay, send back a bunch of these responses and whatever other kind of behavior to simulate the backend business logic. But anyways, I referenced that in the base class for test. So Spring Cloud Contract will bring that in. Here, I'm specifying where the contracts reside. And then a couple of other things that don't really matter too much for this. I'm also here specifying to build the documentation, the ASCII Doctor Maven plugin, and I'll show that here in just a moment. But hopefully this test passed. So yeah, I had 4 tests run and 4 succeeded based on the 4 contracts. Now, if I was to go into my controller class and then comment something out, so I'm removing the find all produce endpoints. So I remove the endpoint that this contract is testing for. Now, if I go back and rerun it, it's going to fail because this endpoint no longer exists. And so this API or this service is no longer fulfilling the contracts. So this is what gives you confidence that, so yes, 4 tests run, 1 failed, and it gets a 4 or 5 because there is like the post I'm checking against, but there's not a get. But this gives you constant confidence that the API is actually matching what the contracts are testing against. And this is what then would give confidence to the clients that are testing against these contracts that they would actually reflect what the real API looks like. It's not like saying, oh yeah, that's kind of what I'm building the API to, but you don't really know, and then you get to production or you actually try consuming the real service and it actually works very differently. No, the service actually has to match what's specified in the API. So if I fix this, I can run it again, and then it will succeed. So this works well on the Java side, but again, if you're a JavaScript developer building out the client, the UI that may be consuming a service, you're not going to necessarily be all that familiar with Java. And as I mentioned, you're probably not going to have like a lot of the Java idiomatic tools like the JDK and whatnot on your system. So really, if you need some way to encapsulate all this logic from Spring Cloud and Java into something that anyone can use and transport around. So here, Spring Cloud contract, they created some Docker images, and here I am trying to run it, and I passed in a bunch of different environmental variables to define, saying like what port in this case is going to be running on 9876, where to pull in the contracts from, and just a couple other behaviors just to define how it should be simulating this mock service. So this is how I'm trying to run this Docker image. And so if I actually execute this shell script, and actually that is running cool. So here in this case, I am running the Docker images, which is taking in these contracts and is acting as a simulation of my actual service. And if I actually go to here, I'm running that service now on 8080. Oops. I'm running that actual service, but here is again kind of the point I was trying to get with the test data. For example, this service is pulling from this like a local H2 repository, but like if you were actually running the service, it would be connecting to like a real database, and that underlying data can change. So here, like it's only pulling back the 4 items that I specified that should return right here. And it's always going to return this result. No matter how many times I call it, it's always going to give like the same kind of concrete result back. Whereas if it's depending upon actual backend data services, that data could change. And that can make it hard to do visual testing. As I was kind of talking about earlier, if you attended Angie's really great talk yesterday, how she was talking about a tool for doing visual UI testing, but one problem is it's always kind of difficult. They do have some tools to kind of get around it, but it's always kind of difficult to handle that variation in test data. But in this case, this service is right now connecting to that live service, but I can actually have it, one of my colleagues, or a person I worked with, he built out this really simple Angular application. And I'll give it a moment here to start. But here, it's actually connecting to the mock service that we have running here right now to test against it. And so we can do like an example of what if we send different things to it. Like it will say here successfully added, so you can have like your UI test or Selenium test or whatever it is to test and make sure that it can actually, like your UI can work with this backend service, but it's not going to change the values that are coming back here if, like, for example, you're doing some sort of thing that could cause a state change. So that way, like, you have like visual tests that can be much more reliable for this. You can also show an example of like, hey, if I send Apple, it's going to reduce the results. Again, this is calling back to that backend UI service. But if I send, hopefully this will actually, yeah, that's right. Unfortunately, he was over eager and actually added validation to the front end of this, and so that will fail. If we bring up Postman here. So here, I'm just going to be calling this mock service here, and I'm not supplying a name. And in that case, I will get back what's specified in our contracts that our missing value is required. But the nice thing again of this is that you have a stable backend to run against, that it's not going to change. You're not going to have to worry about a backend service being down or misconfigured that is going to cause tests to fail. You have a really reliable automated test. All right, so to kind of loop this back to those initial scenarios I talked about. So poorly defined services aren't as much of an issue with contract-driven development. You have this API that is documented automatically as a result of the process. You have accurate documentation, which can encourage the discussion on design consistency. So this documentation that's being generated, and I'll actually, before, I forgot to show. So here's some documentation that is being generated from these contracts, and it shows like where the URL resides, what the response body would look like. An example of response is an example of request, and like how to call it, and so on. But all this is these parts of it are automatically being generated as a result based upon the contracts. Hopefully one of the things that they're going to add to it is an ability to better define like maybe the fields and more information about the endpoints. There is a ticket out there requesting that, and hopefully maybe they'll implement that here in the near future to kind of make this documentation a little bit more rich. But all the same, because this is all being generated from these contracts, and again, these contracts are testing the API just to make sure they match, you can be sure that this documentation is accurate. And at least how that API is designed is from this index.adoc, which kind of describes what this documentation should look like. And you can look at this code example to see how this is all actually put together. I don't want to get too much into the details because it would be kind of difficult to remember later on anyways. Anyways, we have argument documentation, which can then encourage discussion on consistency and design of the API, because again, you can look at the documentation, you can kind of get the full view of what the API looks like, and you know it's accurate, so you can say, hey, maybe we should change it to look like this, because it will work a little bit better. And again, clients can develop and test against contracts, which give consistent results. You're not going to have to worry about a database being down or something changing that's going to cause tests to fail. So having to do serial development? No, you can develop in parallel. Clients and service developers, once the contract is written, both can begin work. that Docker image I was showing earlier, that was just pulling in the contracts directly. So a client developer, they can write out a contract to say, hey, I'm going to need this from the API, but once that's written, they can then spin up that Docker image and develop and test against that Docker image. And then they're going to be confident that once the service developer implements that API based upon that contract, that it's going to match to the behavior they have already written against. This process can also help encourage the discussion on the API design as well. And then also, we're not going to run into this issue of design changes making to production that cause outages. So because these contracts are part of the build process, every time you run a build for either the client or the producer, they're going to be checked against those contracts and make sure that they still match. So if a producer over the service developer makes a change to the API and they didn't update the contract, then the build's going to break because it doesn't match the contract. So maybe the backend service developer changes the contract and then the API. Okay, so that will succeed, but then the client will fail because it won't match the update to the API. And so when you put this into your build pipeline, you would just want to have checks to say, hey, neither the service nor the client can go to production until both are succeeding again after maybe a change to the contract repo. Changes will cause either servers or client to fail, so neither can get to production until both are still, again, matching those contracts. And so this prevents rogue changes from getting to production where maybe they're going to become finalized because now the client's going to have to update to follow those changes, even if maybe the new API change isn't actually better, just to resolve the production issue. A few final points. So in all these examples, I was showing off REST and HTTP, but Spring Cloud Contract also works for messages, so like Kafka messages and so on. It's also totally okay to change contracts. You know, we have like a saying, at least in the US, like, contracts are written in stone, but it's fine to change a contract. It's just a way of testing that API behavior. Also, they're not acceptance tests or replacements for end-to-end tests. They're just part of your test suite, specifically testing that integration layer. So it's not supposed to be like doing things like resiliency, timeout, performance, edge cases, and so on. That's not the goal of them. They're just supposed to be part of a larger automated tested suite. All right, so that's it. If you have any questions, please stick around. And also here, again, is the links to the code and slides, and also some other great links as well for learning about Spring Cloud Contract. So any questions or? Yes?
Yeah, I think some of us, certainly our company, we've adopted the Open API spec, the 3.0, and a lot of that information is already in the Open API spec, and we do generate a client from it continuously and then use it in our testing. So in a way, we're doing contract-driven development. Is there a way in which those two interact so that we're not repeating ourselves between contracts written in in the Spring Cloud contracts versus the ones that we're doing in Open API?
Yeah, so I mentioned that I haven't used it, but I had heard that there is like a third-party library where it can take in like that Open API specification and use that to generate Spring Cloud documentation or Spring Cloud contracts to then do that development and testing against it to make sure that, so obviously like at least some of that Open API is being specified based upon what you actually have written. But like, I guess if you have like what happens when like a 400 error occurs, like that's not necessarily being checked. You're just kind of like writing that out yourself correctly or.
Right. So there's probably no substitution for just checking all of the conditions like in a stateful service, right, as opposed to a mock, because you're like, okay, I saved that, now I want to get it back. If I get a 404, that should be a problem.
Exactly. So I think like if you were to like say within like your Open API, like an annotation like says like, hey, under this condition, like a 400 should occur. Like that's not ever being checked. You can just show that as a documentation. But with Spring Cloud, with that third-party library, it can take out that Open API specification, create a contract, and then test your service to make sure that it's actually matching like some of that behavior. So yeah, there's a third-party library. I haven't worked with it personally, so I can't really say like, oh, it works great and it works all those annotation or on those edge cases, but it is there. So that way, again, so you already have all that open API work, and you can kind of use this to start checking against it without having to like do all that work again to check it out.
I see the real value is like having a stub for the other side. So I'm
yeah.
the producer, and they're trying to figure out how this all works.
Mm-hmm.
They can't hit my service yet because it's not deployed.
Yeah, exactly. And I think that's one of like the real hidden values, is particularly from the client side, is having that real stable backend that's not going to ever change because of test data changing or something like that. They can really then also for like your UI test and other kind of tests, that it's not going to be like, oh, this test failed, but that's just because, you know, they're like one more item was added and like that changed the UI and that just breaks it, but like it still works. So that's one of the real big benefits, like you said.
Deterministic nature of those tests.
Exactly. Any other? Yes. I'm not sure. So yeah. Yeah. I don't know. Maybe, but yeah, I haven't checked that. And then I'll get you. Yeah.
I was wondering, I didn't really know about this Docker image that you could run. I know from WireMock that when you have some stubs up, that you can use like the WireMock API to adjust these stubs. Like sometimes as a client you would want some specific semantic, some semantic reason you would want a specific response. Does this Docker image also support that? That you can change the stubs on the fly beforehand?
On the fly, I don't know. So under the covers, that is what Spring Cloud Contract is using to do all of its work. Let's see. So yeah, we have up here how it's building out like all the WireMock JavaScript or JSON stubs, but I don't think you can change them on the fly, because then like that would kind of deviate from what you wanted to do, because if you change it on the fly, that doesn't really match what the contract was specified.
Of course, like not necessarily for the contract purposes, but sometimes like when you're like locally developing and you want some specific response that is not in the contract, just to test out something semantically, which the contract is not really meant for.
Yeah.
I know at least that WireMock has some API where you can just like change specific response a little bit.
Yeah, no, I understand what you're saying. And in that case, that might be like a different kind of testing you may be looking for. Or what you could be doing, if like you're actually looking out to develop it, is you actually are writing out that contract, you commit it to wherever you're going to be pulling it from, the GitHub repository, whatever it might make sense. You're saying like, oh, actually the API should look like this, you commit it, and then you just restart this, and it's going to pull in that updated contract to kind of do that as well. But it might also be a slightly different kind of testing, and that's kind of why I point out that this isn't trying to replace all testing, it's just part of the testing suite. But we can talk about that a little bit more as well. You also had a question?
This is only for Spring services.
No, it can be for anything. So this is, again, like where the
test execution.
No, so in this case, I am showing a way of pulling in those contracts and acting as a mock, but they also have a second image that can take in those contracts and then test a arbitrary service to make sure that API is doing what you're expecting it to. In that case, you would have to have that service running to have it test against it, but it isn't required to be, the backend service doesn't have to be a Spring service. That API, or they have another image that can then take those contracts and test an API to match it as well. Yep. I think we're close to the end of time. Any other questions or anything else? Okay, well, thank you so much, and thanks for coming up, and hopefully you found it interesting. Thank you.